Well, hello, hello. Welcome everyone. As always, let's try to get the audio levels in check. I think I'm gonna bump my microphone ever so slightly. So let me know if it's too loud. Something like that. Hello, hello, testing, testing. All right, the levels look kind of all right from where I'm sitting, but do let me know if they are not. So, Friday afternoon. Today we're gonna do a little bit of tech preparatory work for a particular effect that I need for the game. Oh, right. I should probably actually advertise our new Discord server. Yay! So, finally got off my ass and created a Discord for the game and the project and the company and everything. So, this stuff interests you, by all means, check it out. Just opened like a day or two ago, so pretty small still. Anyway, let's hope I have all my tools set up so that they actually work on this machine. Let's make sure we have the engine built here. And then let's make sure we have the game built. Maybe we should actually rebuild this thing. I'm in the wrong folder. Let's go to means. Remove the Zig cache and rebuild. Right, so as soon as this has built, maybe we should actually just try to launch the game. Yeah, I've been doing some work on another machine lately, so it might make sense to actually verify that this stuff actually works. And it looks like it's working. Alright. So we're gonna hang around a little bit more in the particle editor. So this is something that I've been working on lately. In the previous stream we actually got stuff actually previewing here in this preview. We can just run this thing and get the effect displayed here. According to this node graph that we have going here on the left. That's all nice and good. Now, some of this work I have been doing in preparation for a particular effect that I want to implement in the game. And that effect is a smoke pillar. So we have some smoke pillars here already. They're mostly for like distant particles. We have something like this, and you're basically supposed to view it from like, I can't actually even really see that, but if you use the distant one, you can just go very, very far away. We can even toggle off the grid here. So this is supposed to just be like in the background of a level, like very, very far away. Several kilometers, essentially. And it would look something like this, right? But I also need a version of this, and I'm not saying this is necessarily done and finished and looking all that nice. But still, we will need a version of this up close, and it should look significantly more detailed and nice and vivid and all of that. And so a lot of this work that I've been doing for the particles lately have been sort of for this one effect, because it's kind of like a set piece in the game. And I was thinking that I want to introduce some new sort of forces, or not necessarily physical forces. We do have some physical forces here. We can apply force, which we actually do here somewhere. Yeah, here we go. Apply particle force. So we just give it a vector, specify whether or not it's in local space or not, and then it just moves particles around. You can also just set the particle position with a set particle position node. It looks like this. And I think in some cases, rather than just using forces, I might want to actually just set the positions directly. And basically control exactly where the particles are going to be. Or at least be able to do that. I don't necessarily want to control exactly. I might want to introduce some like randomness and stuff like that into the mix. But the idea is basically anyway that I can just calculate a position somewhere and then just move the particle there over time. And one reason for that let's see if I can find like a good image. Yeah, this is actually kind of interesting. So from like iStock photo. Well, anyway, this is more like a fire than a smoke, perhaps. But the idea is sort of like the same. You have these kind of embers or whatever, kind of like rotating around. You can see that there's sort of like a directionality about this pillar here. And I'd like to be able to actually have that in this effect as well, to sort of rotate it, because that's quite often what happens when you have these like large bodies of like warm air moving upwards. They start to sort of form like a spiral almost. And so you can do that in many different ways, of course. You can just start with like let's go back here to the front. Yeah, this is an in the distant rendering path, so it's sitting sort of annoyingly on top of the grid there. Let's use this one instead. Get it sort of nicely on top of the grid. Hey Jim and Daba, welcome to the stream. Anyway, yeah, I should probably actually advertise this stream in the usual places. Let me just quickly do that, so I don't forget it completely. Right, there we go. There we go. Anyway, yes, I was saying about the sort of spiraling of these embers around the main pillar. You can do it in many different ways. You can spawn a particle somewhere sort of next to this, and then have it sort of with forces sort of move up through the air, and in sort of like a spiraling way, or like almost sort of like a helix or something, right? That could be interesting. Another way would be to actually just draw a path for it to follow, and then on top of that path we can add some like randomness and modulation and whatnot. That's another way to do it. And I was thinking that wouldn't be super tricky to actually do for for this particle engine. Add sort of add a node which basically holds sort of like a path through space, and then you can just sample that path, and you can have particles move exactly along it, or you can then just use that position along the path and add some like noise and stuff to it, or rotate it, whatever. So I'm thinking we're going to start with that today and see where that takes us. And so, unfortunately, it's going to be like a lot of work if we want to be able to draw the path in here in this thing, because this is just a preview. There's really no editing. This thing here runs sort of like a stripped down version of the game, or actually it runs the full game, but it runs the game in like a stripped down mode. And it would be quite a lot of work to actually make it possible to draw these paths in here. But what we can do is draw the paths in the level editor, export the data out of there, and have a new node in here which can then just eat that data and generate the path for us, and then we can draw it here in the preview. That shouldn't be more than like half an hour of work or something. So maybe that's what I will do, and we'll see where that takes us. And then later on, maybe I'll actually add some like editing to this guy here. Well, that's gonna be a whole different set of work. So what do I mean when I say that we can draw it in the level editor then? Let's see. So this thing sits at Game Merlin Effects Refinery, Smoke Pillar, right? So this folder. Let's create a new level, just a level that allows us to draw these things. New level. Let's make that full screen. Why not? Why not? And just to have something to like work on here, let's create a new terrain and make the vertical range like really small to move it up here. So now we have this big huge plane here of things. We can move it to the origin. Why not? So here's the origin of the world. Maybe we'll create like a primitive geometry. Let's make like a sphere, radius 1.5. That's a little large. 1 is probably good. Like so. We can give it a color just to make it stand out. Are you aiming to keep the particle system completely dynamic? I've seen a lot of time designers tend to prefer geometry shapes plus shaders to create similar fires. Geometry shapes plus shaders. Are you basically are you saying that you would have like a rough shape, sort of like a sphere, for example, and then in the material you do all of the cool things that makes the particle system sort of look nice? Is that what you're saying? If that is indeed what you're saying, then there's nothing stopping you from doing it here. This is using just normal meshes and materials, you know. So we can just do like I've been demonstrating this with the wheel. We can have that's probably wheel preview. Now we have wheels here. They're kind of large and inside of each other. But this is just a normal mesh, or you know, we can have a, I don't know, tree trunk Now we're spawning tree trunks. So these are just meshes. It sort of depends on what particle renderer you're using. You can also have billboards, which are sort of quads that face the camera, and then you can have a material that draws anything to that camera or to that quad. If you model the plane that has the spiral shape, if you modeled a plane, how can a plane have a spiral shape? A plane is flat, right? Yeah, I'm sorry, I probably just don't understand what you're saying here. Or do you mean like you have a plane and then the spiral is on it and then you read it as a texture and like sort of drive it through that way? Is that basically the idea? Either way, you can do that too, because you can just use any material, right? This uses a smoke pillar material, and if we look at the smoke pillar material, actually that's a smoke pillar distant. If we're being completely honest here, it's this thing. So yeah, I think the vertex is. Yeah, this is just a standard vertex shader. Yeah, there's nothing special about this at all, actually. Let's get the object color. Yeah, then we store the clip value, so that the clipping here is the thing that makes these make them sort of dissolve like this. Otherwise, they would just go away at some point. But yeah, like I said, there's really nothing preventing you from doing that either. If you want to have a material that like reads some texture that you write from somewhere else, then you can do that. You have the whole renderer at your disposal, essentially. So I don't think we should be limited in any real sense here. So we have a billboard renderer, which draws a billboard. And you just give it a material, and then we have the SDF particle, which is a little more complex, and this is sort of like experimental. That's why I'm not really using it in the game currently, but it can be seen in one of my shorts if you look at the one with like an SDF smoke effect. It uses one of these guys. Hey Dudu, what's up? This is a reasonable effect. Yeah, it's not my favorite. Let's see where this is actually used, right? So if you go to just save this. So this is where we're going to draw those curve paths. So let's do like smoke curve paths. And this is not a level that I'm going to export necessarily, even though I can if I want to. But this is really just here to sort of host those curve paths, so we can export them out of here. Right, so if we go to the level that actually has this effect, which is in, not here, it's in here. And if we go to smoke pillar, we can just start it. Bloop. So here is actually where this thing is going to be visible. I'm going to actually have to decorate this level soon-ish. I'm probably going to do it on stream. I'm going to try to like, I don't know, my plan is kind of like to just like sit down and like decorate this in like 8 hours or something, like all in one go. This is the intro level for the demo, so stay tuned if you want to see that. And this is where the actual level is going to take place, or takes place rather. And there's going to be a large smoke pillar there. So this effect is supposed to be, or only supposed to be seen here at this distance. And that's why even though, thank you very much, if you think it looks nice, I don't think it looks very nice up front, or up close rather. But I think it looks kind of reasonable at this distance. So I'm basically figuring out how to make that look cool up close. That's why I've been looking into like curl noise and all kinds of things. But anyway, so here's the use case for that. And now if you go back to our smoke curve paths level. Right, so let's say we want to make this is now the center of this effect. Should maybe move this off. Well, first of all, it should sit on the exactly on the origin if you want to actually pretend that it's on the origin. But maybe we don't actually want to. Let's do like smoke pillar 1. And under smoke pillar 1 we'll actually move this under smoke pillar 1, and then we'll move it like 20 units to the right. So boop. There we go. I'm gonna put actually another one. Let's move it here. Call this origin. And it sits at the origin, and its color is black, like so. So if we want to have like more of these, we can sort of work on them in isolation without necessarily being all that annoying. All right, so let's say we have this is the base of the huge smoke pillar. I want to have some of those things sort of swirling around. How would we do that? So, and this is all just like, I'm just winging this. I really haven't prepared this in advance, but I'm thinking this is how it could probably work. So we have a curve path. A curve path is an object that generates a curve path from all of its children, specifically from all of the children that have a transform, right? From the positions, generates a smooth path from the position. So if you like put a waypoint there and a waypoint there and a waypoint there, we need to check that checkbox there to make sure that we can actually see it. Just those 3, thanks. Now we can move this up, and now if we move these around, it makes a smooth path through these guys, and we can just extend it like this. And that's really handy, because now we have this nice path through space, and the only data we need to actually generate this path are these points, and specifically their position, right? So this would be very nice to be able to just like put these guys in and move them around in here. That way we could just like click and get a nice path. But like I said, that would be quite a lot of work right now, since this thing is really just a preview. There's no editing. This doesn't understand editing at all currently. All the editing is happening here. But still, that would be sort of the idea. So now we could let's add a waypoint and move it to start there. Actually, let's have it start a little underneath it, like so, and then just move it up. Like that. Maybe we should have one like right in the middle to make sure it actually starts from the center. But then you can like you can move this down. To sort of shape it, like if we keep it very close to that, then the shape is sort of changed. Hey Matt, early stream, yeah. Yeah, I just had lunch and I was like, screw it, I'm just gonna do some work on stream. So 1, 2, 3, we have one additional here. Let's take that away, move it upwards. Winging it proceeds on doing it like professional people. Well, I guess technically I am a professional, right? Not not to rub it in or anything, but I actually do. I do get paid to do game development, so I guess I am a professional. But I'm very much not like a professional tech designer. So in that sense, yeah, not paid to do this kind of thing. Right. So I'm not really. I don't really know what I'm doing with this. If this is the best way to get one of these swirling things done, but anyway, let's go with it. So we just copy this guy, and we need to move these now sort of upwards in a sort of helix-like fashion, right? While trying to make it, I mean, it shouldn't probably be completely sort of cylindrical. Probably just looks cool if it's kind of not that. What's the word I'm looking for here? If it's not that kind of regular, I guess, something like that, right? Sometimes being the professional is knowing how to wing it effectively. Yes, I guess so. I guess so. To be honest, I wing it for most of my things. I guess it's like the curse and the blessing of not really knowing what you're doing, or if it's a good or a bad idea. But anyway, yeah. So something like this, right? And then we can have more of these. And the cool thing, of course, with this now is that you can just take the position. You can sample this path along this curve here, and then you can modulate that position with something else. But like if we wanted to, we could do, is it path animation? Yes, it's path animation. So this guy wants a position path. Look at target mode. We'll just, you know, do position path direction. Transform reference object. Nah, I don't think we need any of those. Let's build that and let's preview it. So now you can see sort of like this, I don't know what to even call that, like three axis, like a coordinate system moving up the thing. So you can sort of imagine that being a particle, sort of swirling around the smoke pillar there. All right, so I'm kind of feeling my microphone like being a little. I'm gonna lower it ever so slightly because I get like a little bit of distortion here. I don't want to do that. So, talkie, how loud do I usually talk? I talk like this, blah blah blah. All right, maybe that's better. Let me know if you can't hear me properly. I'll try to adjust it from OBS instead. Cool. Okay, so now we have this swirly thingy here. So how do we now get this into a particle system? That is the question. And I don't have like a good answer for this currently. I just have a bad one. Talking about winging it. I kind of don't want to. I mean, I could export this thing as it's a serializable type, so I could export the data and to load it from the effect, I guess. But I don't necessarily want to do that because then it's not really editable there in the effect at all. And so what I was thinking is I have this special command here. I have a few special commands. Extract positions as JSON and create objects via CSV, of all things. This is sort of like a menu where I dump special commands that I need for some very specific purpose. Today we're lucky in the sense that we can use a pre-existing one. I don't remember exactly what I needed this for. Oh, actually I do, yeah. You can, if you want to do like a if you want to model a convex hull out of points, then this can be handy. You can get them out as JSON. We can use this for this thing as well. Let's get rid of the path animation. We won't use that. We take these guys, and we need the full path of the parent. No, sorry, we need the full path. This guy doesn't have a transform. No, we need the full path of the primitive object geometry. Let's call that something like root. Copy full path, select those guys, and then we do extract positions as JSON, enter the full name of the parent, enter the root thing there, and now we get these positions here as JSON. So now that we have this, we could take I have it copied to the clipboard as well, as you can perhaps see there, which means that we can basically just create a new node that allows us to quite simply just eat this data. Right. Let's make sure that actually works. If I just select those guys and I don't input the root, so now that would be in world space. Yeah, now you can see that basically affected the x coordinate of them. Good. And of course we want them in the local space of the root. Looks very similar to Roblox Studio. Oh. You know what? Someone asked me why I'm using Roblox icons previously. So like, you know, these things up here. Like, why do you use Roblox icons? And I wasn't sure what he meant. So it might be that Roblox Studio uses the same icon set as I do. But if you're wondering what it is this silk icon set. So, fam silk. You can see the icons here. These are just free to use for anyone. So I'm assuming that Roblox probably uses the same ones, right? Is that why people are connecting my editor and Roblox? But yeah, anyway, fam silk. Those are the icons and icon set that I use. Right. Anyway, this is the plan for today. Let's create a new node in the particle engine, into which you can copy this thing, and then you can sample the path. You give it basically a t value. A t value goes from 0 to 1. So it starts here, and then like 0.5 would be sort of halfway through it, and then 1 would be up here. And you kind of just get the position. You can also query this for the direction, so let's expose that from the node as well. And that should hopefully allow us to make these kind of nice embers that sort of swirl around the main smoke pillar there. Let's save this for now. We can come back to it in a bit. I'm gonna unload that thing so we can make some changes to the engine. Alright, and yeah, I think we can probably just shut this down as well. Right? So the node that we're going to create, it will work sort of like this curve node here. The curves you can actually edit here directly in this because they're not 3D, so you don't need like a 3D view for this. I have this curve editor, which is honestly kind of terrible. Should get a lot of love to be usable, really. But anyway, so the curve will be, or the node will be sort of similar to this. You give it a float in here, and you get a position out, and then probably also a direction. And then we'll need to have like a button, kind of like this is also a button. Except it would just give you probably a text box, a multi-line text box. Not unlike what we have here in Nemo. If you have a multi-line dialogue node here somewhere. Here we go. Yeah, something like this. There's an edit button, and then you get this sort of dialogue when you can just paste the JSON in there. That should be good. Yeah. Then maybe we'll even need to do like JSON validation and click OK so that we don't paste just some crap into it. Okay. Start with that. Close that as well. Yeah, that's our reference. Let's move it off to the side for now. In fairness, Unity, Unreal, and Godot all have very branded looks, but since you're using WinForms, a bit more general. Yes, it is. It is. I don't know what does Roblox Studio look like. Let's Google it. Let's Google it here. Roblox Studio images. What does this look like? What? That doesn't look like Silk icons at all. Maybe it's like an older version that people are referring to. Yeah, this looks nice. I mean, this looks nicer than what I have, to be honest. But I don't see the resemblance. Roblox for Unreal, alright. Yeah. Yeah, I'm gonna assume it has looked more similar to what I have at some point. Yeah. Alright. Well. Good stuff, good stuff. It doesn't really seem to be, at least I can't find anything that looks more like Silk. Oh, there we go. Is that it? Yeah, that looks like Silk icons. Yeah. Yeah, this is sort of blurry, this image, but you can see that we have these sort of Lego pieces. There's one, and I think I'm using the other ones as well. I don't remember. Yeah, yeah. This is using Silk icons. So, okay, cool. All right. But yeah, fair enough. Yeah, this is really not branded in any way, other than I have this. This dark skin here, which like you wouldn't believe the kind of hacks that I've had to do to make that happen in WinForms. Jesus. All right. Let's open the tools solution here. Yeah, and the nice thing, of course, with this having these curve paths here is that I can just define basically anything I want. I can also do like the main smoke pillar if I want to. I can drive it through the curve path as well. It should be nice. Alright, just close everything. Where should this go? When you work on the path, can you just ramble on what approach you did to render the lines? You just sample the curve to render the lines. I don't remember like by heart exactly how it's done, but yeah, I think I just actually curve path 3D. I think I just advance along the curve a little bit. Yeah, there we go. Debug draw. So there's one of those classes that I have duplicated in C++ and Zig. Like I tend to use these curve paths from Zig most of the time these days, but the original one is in C++. It should work basically the same. Just testing apparently. But yeah, you have a curve segment. You have segments, so it's made up of cubic Beziers between two of these guys here. So the lines from this to this is a segment. And then, from this one to this one, that's another segment. So we have a bunch of segments. Apparently, I just split all the segments into 30 pieces. And then I sample at that point. And then I draw to the previous position. There you go. That's it. And then you can draw the control points. You get these sort of handles. They kind of look like you should be able to move them around, but you don't actually, because the way that you do this is by actually moving these control points here around, and then the handles are for the control or for the curve path. They are actually sort of hard coded to be smooth, so it adjusts those itself. So that's it. So yeah, what do you call that? Is it like integration? What is the mathematical term for doing it like that? I don't remember. One thing that you might want to keep in mind if you want to do a path animation, that we just take this again and just plonk it into there, and direction. Then we preview this thing. You see this thing is moving along this line, and it might look that it's not actually all that smooth. Like it kind of looks like it's moving faster along these tight points here. As far as I know, it's actually mathematically impossible to sample a Bezier curve at equal distances along the curve. So basically what I do here is I have something called a lookup table, which you can set here in these advanced settings. Basically, when we build this path, we sample the Bezier a little bit, and we track how long we moved, and then we have some distance that we actually want to move. So we go forward or backward until we have sort of points along the Bezier curve that we then actually can use to drive something that's supposed to move sort of faster or slower. Or I'm saying it incorrectly. If you have something that you want to move at a constant rate along this distant wise, then you actually sample the lookup table for that. And that's why you have let's see. You have sampled Bezier. This is sort of like the correct mathematical way of sampling. and then you have sample lookup table, and you can see the interface is exactly the same. You get like a position and a direction out of it. And the Bezier is sort of like this. This has kind of like almost infinite resolution. The floating point is 32 bits run out at some point, but still within the floating point space you have sort of infinite resolution. And then you have the sample lookup table, which is more or less constantly advancing along the curve, but its resolution is not actually infinite. So if we do like we increase the step here to something else, and then we build this animation again, you can sort of see it like it's not even really staying on the curve anymore, because it's like linearly interpolating between those points that we did, make it even larger. And now it's kind of jumping between them. And now we have just 10 points, I think, along the curve. So yeah, now you can like clearly see it just jumping from point to point. Yeah, so that took me a little while to like figure out like how am I actually supposed to like sample this at a constant rate. And as far as I know, you can't actually do that if you just have many Bezier segments one after another and want to sample them. It's not possible. If you have a longer Bezier segment, then it will advance faster along that segment than the other ones. And so it's very important to do something like the particle movement along these lines to have a lookup table that you can sample instead. Anyway, I digress to some extent. Let's go back to the stuff. Let's go back to the stuff. Change this to a binary search. Yeah, I probably should, but probably hasn't ever come up in my profiling. Yeah, here's how we build the lookup table. You just sample it according to that value that we played around with there. All right. Let's make that new node. But I'm wondering if I should put it in Sprinter, which is the sort of base which all of those node editors use. Actually, not the material editor, but all of the execution node editors. They run their node graphs on something called Sprinter, which is the node graph execution system. And so it has a bunch of math nodes, and this would be a math node. Like you can make integers, and you can make floats, and you can make vectors, and do all kinds of things. But there's one thing that makes it a little tricky, perhaps, to put it in Sprinter, and the reason I would like to put it in Merlin instead, because I'd like to debug draw those paths, just like we had in the editor before. I'd like to be able to see them in the material editor. Let's have a look here. Yeah, okay. Yeah, so what I was looking for was this. So I had previously something called a flow field, which I took out this for now because it didn't really do what I wanted it to do. But it was basically a flow field, like a three-dimensional volume in which we have a bunch of directions. You can sample it for the direction. That node has a debug, or had a debug draw flag, which we can see here. And we can debug draw things by hooking into the Merlin effect, right? Like this, at an update callback. And so that will work both in the editor and in the game. That's very handy. But we can only do this if we actually put this thing in Merlin, because like the Sprinter standard library nodes have no idea about any kind of update callback. Unless we make the system actually aware of that. But let's not do that now. Let's just put this in Merlin for now, because I think like the other places this is used is in the audio engine and the mission scripting, and I don't think we'll need any curve paths in there anytime soon. So we'll put it in Merlin instead. We have nodes, we have math. We actually have some math nodes, but color vector node and curve node. Right, so the curve node is even in Merlin. Well, then that makes it quite clear that this is the correct place. So we'll call this curve path node. Should we call this like curve? Let's call it JSON curve path node. Yeah, let's call it JSON curve path node, because I'd like to believe that at some point I'm going to add like the editor, which would allow me to just draw these curve paths directly in the particle editor, and then that would be maybe just the curve path node then. So copy the curve node. Right, so what do we need here? Convert to Sprinter. This is where we can then actually serialize the data. Do we actually have a curve path? We don't have a curve path in C#, so we won't actually serialize the curve path itself. We'll serialize the positions, and then we can construct it at runtime. It would be nice to be able to serialize the whole curve path, because then we could pre-compute the lookup tables and all of that, but it's not really a problem. Right, so we'll have an input pin, which is like T, right? T. We'll have an out pin, which is a vector variant, and this would be position, right? Position pin. I think I'm just gonna call that T. T goes from 0 to 1. I think most mathematical literature calls it T. At least the one that I have looked at. And direction pin is the other one, the other thing that we will be getting out of this. Direction. Right, and that is a single value. These can be connected to multiple ones, so that's fine. Actually, what we will be serializing here is the string for the JSON data. Set it to empty. That's fine. JSON data won't go into the game, but JSON data is what is serialized here in the work document for this particle system. Right, is that all we have? I think that might be all we have. Currently we don't have a blah blah blah. Run it to JSON blah blah blah. Yeah, okay. That's fine. So let's make a function here that we call private do vec3 get positions, something like that. And currently it can just return a new empty vector3 array 0. And then here we can actually serialize that, right? Vec3, yeah, get positions. That would be node.getPositions. Let's close the thing. To bool, what? Doesn't it be like put serializable or something like that? I don't remember how this works. Serializable. A list of T. A list of vec3. Okay. Used to be a list, I guess. List of vec3. New list of vec3. And there we go. So we can just add a to-do here, but we will actually want to deserialize this JSON data into a bunch of points. That should be fine. Alright, so just like always, when we add new nodes, we need to add the UI node separately. And that goes here in the Merlin editor. So what did we call it? JSON curve path node. And again, I'm gonna copy the UI curve node. I'll just take all of those. Whatevs. UI node base. So JSON curve path holds a JSON holds a curve path defined by JSON data or something like that. Okay. Yeah, let's just copy this. Let's copy basically all of that. Curve image, yeah, it's the thing that actually draws the curve there. Don't have anything like that. I don't think we'll want to have that either, but let's keep it there for now. And now we need to match it with this guy. So an input is of T. The outputs are position and direction. I've been meaning to just make this nicer since forever, so that I wouldn't have to actually list these in both places, but I just haven't done that. Right, so here we have something called an ST node curve button, which we don't want to have because this is the thing that renders the curve thing for us. Instead, what we want to have is a button that allows us to run like a piece of code. In this case, we will show the dialog to be able to just insert and edit the JSON. Let's look at the multi-line dialog node in the Nemo editor. This guy has it, so it's just an ST button. That looks nice. And ST button is set up to do show edit dialog. Yeah, so it just runs a private method, shows a dialog. Multi-line dialog. Awesome name. Okay, let's move that off to the side. So we'll have that. Of course, we won't be able to see any visual representation of this curve in this node, but that's really not a problem. You can see it right there in the preview if you want to. We don't have any curve data. What we do have is JSON data. Right? That's a string. It's called JSON data. JSON data. Like so. Rectangle, alright. Yep. Add that. Add it. Show edit dialog. Yeah, that looks like a good name. It's just a private void, yeah. Not taking any parameters. Okay, good. Just put that there. Yeah, and we'll need to create that dialog. That shouldn't be tricky. Let's do a to-do for now. And what else? We need to size that button accordingly. Let me do a little bit of quick math here to figure out how big that button should be. Right, I think it should be 68 wide. Oh, that's actually not. The width is over there. Okay. Yeah, so that's the width. It's 114. Let's see if that holds up. Right, we don't need the X and A stuff. We might actually need the Merlin. No, I don't think we need the Merlin editor. We don't need the curve control. That should be fine. Okay. Yep, alright. This looks good. Let's assume this is fine for now. Let's do the node mappings is the last thing that we need to do. So we need to go here to the math nodes. Already had the curve node here. JSON curve path node. And same thing there. So now we should be able to create a node graph and add this new node type to it. Let's make sure that is the case. So math, JSON curve path, looks like that. Well, that looks fine. Maybe a little unnecessarily big, but we can edit that later. That's no problem. Maybe I'll want some new pins anyway. So the pins actually position themselves automatically, and you can even have the whole node size itself automatically according to the pins, but it doesn't really know how to size itself according to like controls. So things like this button here, for example. But yeah, that looks good. Now we'll want to do that dialogue there too. Make sure we can actually edit the JSON stuff. I'm thinking I'm probably using like a scintilla control here for this. This is probably a scintilla control. But that's basically because I want to have like auto completion like this. I don't need that for the JSON data. I'm wondering if I should just quite simply use like a text box, like a multi-line text box with a monospace font. Is that enough? Is that good enough for the JSON data? It probably is. Let's start with that and see what we get. UI. Okay, so what should we call this thing? It's basically like just JSON data that doesn't really know what JSON data, what the JSON represents. I'm thinking, should we make this like a curved path JSON dialog, or should we just make it like JSON dialog? I don't honestly know. Scintilla thing is also just a text box. It is also just a text box. However, it has a DLL. It's a DLL, right? And so if I end up using that, I will need to link to the Scintilla DLL, which I don't currently do here for Merlin. This is Smart Property Grid, because it's printer in the ST library. If we go to Nemo, there's also Scintilla.net. I mean, it's not a big problem to link to that, but it might be a bit overkill. But yeah, it's just a text box, of course, yes. It is. Yeah, I don't really care what we make the dialogue currently. I don't think anyone is particularly excited about the dialogue, so let's just make it. I'm gonna call this something as fancy as text, multi-line text input dialogue. Yep, that's what I'm gonna call it, because we can make it aware of what the thing is trying to be. Later on, we can, when we create this guy, we can give it a delegate, which is like reject the data if it doesn't pass this check. That is actually how I have done several other things. Like if you go to parameter, float parameter node editor. Right, like this st node select string box thing here. This gets actually like a function which gives it the available things that it can select from. So we can just give it a similar function which basically takes the string that you've inserted, that you have input into the dialog, and then returns a bool. And then if the function returns false, then that means that, hey, this thing is not valid. And so then the JSON curve path node here can be the thing that actually treats it as JSON and goes, oh, this is not JSON. You just, you know, input like Edgar Allan Poe's latest novel here. Something like that. I don't know what Edgar Allan Poe wrote. Did he write novels? Or was he a poet? Or what did he do? Okay, let's see if we actually... Let's make it a rich text box. And we'll call this quite simply text box, or m text box rather. And then we'll add a button, which is okay. Ooh, that's small. And another button. What's up with the size here? There we go. That's a standard size. Yeah. Okay. And so now I need to remember how this works. So this would be like the cancel button. This would be the OK button. And then we can set, I think, the accept, or is it default button? Oh, what is it called? I can never remember if you actually, do you set it on the button itself? Cancel button, there we go. So this is that, and I think it is accept button. Accept button is that, yeah. Okay, like so. And then we size this accordingly. Like so, and we'll set this to be anchored to top left, bottom right, and these guys should be bottom right only. Like that, and now we have the thing working. Excellent. As for the control box, I think we don't want to have, what's it called, minimize box, false, or maximize and minimize. So and this is a dialog, so let's not actually have the wrong control selected. Get rid of the control box completely, and we'll set show in taskbar to false, like so. Okay, so now this is like an honest to god dialog, and we will want to have private string m value. Actually, let's make this a public string value get private set, and we'll add that validation thing straight away because it's actually really simple to do, right? Yeah, if I can remember how these functions are supposed to be handled for us, but anyway, string value, that's the value coming in. Then we have func, Right, so you give the parameter and then you give the result. Excellent. So we get the string and then a bool. And that would be a validation func. Very funky. So string value equals value, and m validation func is validation func. Right. Can we set like fonts and things like this in here? I'd like to have like a mono space font. Text. Let's just copy paste that JSON that we already had. Like so. There we go. That looks horrible. We don't want that. There's the font. There's the font. Alright, so what is a good monospace font? Something like Consolas or whatever. Consolas. Is that good? Not sure. What's the font that I use in the multi-line dialogue? It's actually Consolas, the size 10. Okay, that's probably fine then. I do like that particular font. Yeah, that's probably fine. Okay. Yes, and the text box text will also be set to the value, like so. And then we have a handler for OK, a handler for cancel. I'm not sure we actually need to have a handler for the cancel one if we have it set as the cancel button there in the form, but whatever, let's keep it. So if m validation func with whatever is currently in the text box, or rather if not, right? Then we do message box dot show and then we just go the value is not valid, invalid value. I don't really care what this says for now. That's an error. And then we're going to just return. Otherwise, we set the string value to whatever is in the text box, and then we do this dot not click but close. I did the anchoring, yes, very much so. And I can prove it by just resizing this guy. Hello. Everything works. All right. All right, is that all we need? I think that's all we need. I'm kind of not liking this like tab distance here, but whatever. Okay, so now we should be able to use that in the thing, right? So we'll need to have a private bool validate JSON thing here, and it takes the JSON as a string, return false for now. Okay, and then we can do using var dlg is new multi-line text input dialog. What does it want us to do? It wants us to do that. The value would be JSON data, and this would be validate JSON. If dialog show dialog is, oh, we probably actually need to set the dialog result, right? But if that is true, then we set the JSON data to dialog dot string value. That's all we need to do. Yeah, so we need to set this dialog result is okay. And here we can set it to cancel. Does that make sense? Alright, we want it to appear on top of that thing. So now we can just add something and it will go like, oh, the value is not valid. Oh no, oh no. Let's see. So this guy, start position on top of the parent, center parent. Yeah. Should we actually allow it to have a custom title? Something like that, maybe. Nope, not that. And this can be input a list of vec3. I guess it's called an array. Insert an array of arrays, right? This is an array of arrays. Really, it's an array of arrays. Something like that, right? And that should be fine. And then I think what we actually want to do here is have here on the data side have like actually as a static function, which is kind of like the ground truth for how to actually convert those into vec3s. So we'll want to have should be maybe like an I list. So do I list vec3 positions from JSON, and this is supposed to be a public static. Return null for now. So in the validation, like this guy will also need. Oh, that thing doesn't actually. An I list. That's stupid. Why don't we support that? That should be like an I list, right? I list. I list. Yeah. I'm not gonna change that now because we're actually creating like a concrete version of these lists when we do like the get out. So you won't be able to like get out an I list anyway. I guess maybe you do. Maybe I don't know. I don't want to change it now. Let's keep that as a list. Anyway, this data side will need to use these positions from JSON to actually do the list, and it will do it like this. It will do it like return right. Actually, yeah, this gets a little more complicated, but it's good. It's not a problem. Let's do JSON data like so, and here we actually want to positions. Oh, positions. Node.get positions, and if the positions are null or position count is null, then we want to throw an exception here. Actually, probably if it's less than 2. Yeah, we need at least 2 positions. To make a curved path. You can't make a curved path with just 1 position. So it just prevents us from exporting the material if you have just like an empty list, or if you have just like 1 position there. Won't work. Okay. So that's good. And this guy now, this can just quite simply get that thing. So we do Merlin, nodes, math, JSON curve path node, positions from JSON, and we give it the JSON. And this needs to return a boolean, right? So actually, what we can do here, if we want to be smart about it, is to actually create a bool validate. Right, then we use the same logic for this part here. Validate JSON. Yeah, let's do it like this. So have var positions. We'll call that get positions from JSON. Like so. So let's do return positions is not null and positions count is 2 or larger. Then it's validated. Get. Like that. That's even nicer. So now if we do like, we can't validate the JSON for node JSON data. Then we throw the exception. That's good. Okay, and now we can just like get rid of that, and we can even just do merlin.nodes.math.json curve path.validate JSON, right? Just give it that thing to actually validate it. All right, we're almost there. We're almost there. I promise it will get more interesting than this. It's kind of boring to be honest. Get positions from JSON, right? So I am typically using Newtonsoft JSON.net for all of my things. And so basically we can do this. I'm just copying this from off screen here. All of that should be fine. We'll have a test JSON, and that should be probably like system IO. Yeah. So we have a bunch of positions, and we will now create. Like, okay, first of all, if we can't just parse this, then I'm going to return catch can I just do like catch without any exception? I think I can. Return null. That's good, if we can't actually return this thing. And then we need to do like var list is new list of vector 3 for each p in positions. I have to list add new vector 3p, and this is now like p0, p1, and p2. Right, something like that. And then we return the list. That should be good. So that gives us a list of vector trees, and then we just put that there. Perfect. Yeah, and then when we do it like this, we can just like get out a stud vector of vector trees on the C++ side, so that's nice. That should be really good. All right. Let's see if that works. So we'll do like curve, just throw one of these guys here, just do like hello, this is not valid, an empty, oh, I can't press enter here, it selects the OK button, there we go. Yeah, so we need to basically not have that OK button as the accept button, right? Let's take that away, none. Maybe we can somehow configure it to like. Now we can do that. Do the thing. Maybe we can somehow configure it to use like. Oh, and tab also does that. That's annoying. I'm just gonna use 2 spaces for now. 0, 0, 0. 1, 1, 1. This should now be valid, and it is. Yay! And if we edit it, we get it back. How cool is that? This should not be valid. Indeed, it isn't. Yeah. Oh, this text box is so bad for actually editing. Like this should not be valid, right? That's not valid JSON data, or actually it is. Okay, at least. JSON.NET seems to think it is. I actually think it shouldn't be. Like this is valid JSON data, right? This thing. This thing should not be. Yeah, I don't know. Anyway, the important part here is that we can take now this stuff, which is the actual honest to God stuff, and paste it in, and it goes there and it stays there. Good. Good. That's what we want. And now we should actually even be able to export this thing and have it running. Of course, we won't be able to run the thing because we will get an assert failure that we don't have a JSON curl path node. So that would be the next step. And that should actually be quite simple to do in comparison to this. So that's nice. All right, let's make that happen. Have some coffee. But my coffee is kind of getting cold. Alright, so the path that we want to look for is this thing, Merlin nodes math JSON curve path node. Let's just paste that into text file for myself here. Alright, so this thing, early nodes math JSON curve path node. This is what's going to be found in the data, and we need to register something for that. So let's go to basis, Merlin, include nodes. What have the curve path or the curve node here? It's actually probably registering it's registering just a normal Sprinter curve node as the Merlin curve node. So probably what happened here was that I needed to have the runtime is using just a straight up curve path, or curve in this case. So it can be found in Sprinter, but the editor side requires some special like curve components and things like that I didn't want to put in the Sprinter editor side. So I'm registering like a Sprinter node as a Merlin node. This as this, but that's fine. Here we have the Merlin nodes, so we're just gonna put it right next to one of those guys. So let's do curve. Oh no, it's called JSON curve path node. So we need a header and we need a CPP. Like that. Then we need to go into CMake lists and add it here as well. Like that. Alright. Regenerate those. Reload. Nodes. Let's copy that from over there, put it here. So call it register JSON curve path node, and this is now the place where we need to put that whole path. So like that, and I guess I can copy this. Yeah, we will have some state. We won't have any update. This is actually a pretty good one to copy from. Like so. Like so. That's good. Okay. And then we have the pins. We need to set up the pins here on the runtime side. So we had a T pin of type float as the input, then we have position and direction as the output. So T is the input, position, direction. Add data pin to the input. So this would be input pins. It's called T. It's of type. Actually, I don't need this whole thing here. Let's go away. Float. Position, direction. That would be basis type vec variant. In theory, they are always vector trees, or shall we say, in practice, they're all vector trees. But vec variant is the type that I use for these vector nodes. Discord re-enabled notifications for me since today. Feels like they want to show off their new Halloween sound theme. I don't understand Discord's notifications. Maybe it's just me. Maybe I'm just stupid. But like, I get like a new message sound every now and then from Discord. even though I've toggled it off, I guess I need to maybe I need to toggle it off for like all servers or something. I don't know why that happens, but I don't have like the new message or message arrived or whatever it's called on anymore. I still get it, so I just muted my whole Discord tab in my browser. I don't understand what's going on with that. They just can't leave me alone, although I'm trying to work. Yeah. Yeah, though this has been going on like forever for me. It's not something that's happened now. It's just like I've never been able to like make Discord shut up. And the thing is that it doesn't work for me. Like I set it to off in my Discord settings. I still occasionally get it. Like what? So I just mute the whole Discord tab. And then sometimes I watch a video on some Discord server, and I'm like, why is it not making any sound? And I realize, oh, I have the whole tab just muted. Yeah. Let's see. Notifications. Yeah, okay, it's on again, yeah. Let's see if I unmute this. That's the new sound. Okay, all right. Yeah. I don't know. I'm just gonna mute the whole tab again. Feels like that's the more reliable way to do this. Yes, and I'm bleeding. I'm bleeding YouTube subscribers again. I do that every time I stream. I lose like 3 or 4 YouTube subscribers. I don't know. People are like they're sick of seeing my stream notifications or something. They're just like, eesh, no. Yeah. Anyway, that doesn't really matter. Let's have a look here. What do we need? What do we need? So this thing needs to have quite a bit of state actually, because it now needs to create the curve path. So let's go into math and do curve path 3D. And actually I like to have the core engine ones up above. And then this guy is a serializable, but we won't be able to serialize it from C# currently without actually adding some code there, so I'm not going to do that. We do have a construct smooth from positions though. So that is what we need to do, and then we need to build the lookup table. We need to do both of these things at runtime currently. That's a little annoying. That's not cool. Like if we deserialize it, not only can we just serialize the whole curve path, but we can also serialize or deserialize the lookup table. So that would be nicer. And I was pretty sure I had ported this to C#, but apparently I haven't. I do have it in Zig. Yeah, here you can see. I have the same deserialization in Zig. So that works, and to be honest, I tend to use this curve path mostly from Zig these days, because it's very, very handy for doing like camera fly-throughs and stuff like that. Oh well, right. Let's make a struct here, struct state, and we'll call it basis curve path 3D, like that. I think that's basically the only thing we need, but I'm still gonna wrap it in a state if we end up having to do some other things. We have a create state function. We can just quite simply create one of those guys. State. We won't be able to do that quite like that, but almost. So what we want to do now is do like a vector of vectors positions, right? Yeah, we should be able to do that. So just get the positions out of that. We can assert that we have 2 or more. And then I think curve path might actually assert that when we're doing it from here, right? Yeah, at least 2 positions needed to construct a curve path. Yeah, I guess like technically it's a little unnecessary to do that there, but I'd like to catch this here as soon as possible rather than inside the curve path. So let's do state, curve path, construct smooth from positions. That would be positions.data, and then that wants a U32, so we give it positions size like that. And then we need to build the lookup table using some sample distance and some step. Let's get those out into actual parameters. Maybe we'll actually want to add these to some like advanced setting section of the node later if these are not good. Build lookup table, sample distance, t-step. Right, that's good. Pin value, we can't do it quite like that. Again, here we want the state, like so. Sprint your user data. Oh, one thing that we forgot to add to the editor side of this thing is the debug draw flag. That's probably something that I'll want to have like immediately here. But let's add this pin value business first, because we'll want that as well. So if pin is position, actually I don't need that. I don't need to do that. This is not Zig. Zig doesn't want me to create empty blocks and then save. It just folds them together. That's kind of how I tend to work a lot of the time. Let's check one of these. Sample flow field node. That's not the one I want to have. Is it that one? Yeah. Yeah, we want the Merlin Sprinter user data. This is the reason we want to have this. This. This node in Merlin is that we can access this Merlin Sprinter user data. We can do something like true. Just sort of, you know, if debug draw as soon as we actually get that debug draw flag there. But we can do UD effect instance add update callback, and this is just a callback that we can hook up so that the effect calls it every time it updates, and that is a place where we can then call the curve path or debug draw the curve path. So I'm wondering, like, Yeah, I should maybe just do like a member. So debug draw here. Probably just be inline. Curve path, debug draw, and it wants like right draw control points. Let's extract these guys as well. Yeah, maybe even the path color could be nice to be able to, if you have multiple of these, which I probably will have for the smoke pillar, and it would be kind of nice to have those things there. But we don't have the incomplete type. Okay, so that would be include render color. Like that, and then we can hook this up. So then we can do make delegate, and for the this pointer we'll give state and address of state debug draw, like so. And that's it. That should be all we need. Yeah. Okay, and now then, this should be kind of easy to do. So if we do, maybe just do the whole logic here inside of this. So vec3 pos, this would be state, no, curve path, sample lookup table probably. Right, we get a position and direction every time. That's just how it works. Alright, so currently we can just do this then. Do vec3 pos vec3 dir, and then pos dir. Is that like an incomplete type thing? Oh, it wants the t, of course, yes. So we'll want to do float t context get input pin, input data pin value, that would be t, and then we give it t, like so. Right, and now we need to wrap it in like a vec variant pos. And we don't have that either. Make variant. That's good. And direction. There we go. I think this should be it. I think this should be basically all we need. But we'll see. We will see. Let's build this. Oh, we can't forget to actually add it into the Merlin node registration. JSON curve path node. Yeah, it's a little stupid that it's called JSON curve path node here, if we're being completely honest, because there's no JSON here at all, right? The JSON was lost there on the editor side. JSON never goes into the runtime, so this could just be like call something like curve path node from JSON or whatever. But okay, it's probably fine. The nice thing about this is that we could register this same thing, since this actually doesn't use any JSON at all. we could register it then for the JSON curve path node, as this is the stuff that is found there in the data. If you had two different node types, one is like allows you to just place those positions, and the other one is this one that we have now, which reads them from JSON data. If the output is for both of them is that we have a list of positions that we want to build the curve path from, then this could be called something like curve path from positions or position curve path node, and we can register it for JSON curve path node and the fancier one as well with the same runtime data, but we don't have that yet. Anyway. Right. Now we have this thing here, and we should be able to basically create an effect here. So on start, we need to somehow reference the node for it to be picked up there. So what do we do? Let's make let's do a repeat. Once every second we spawn a particle or emit a particle. Move all of this to the side, like so. Spawn it here from the local center of the effect, and I think we'll just go to updating the particle straight away. I'm actually going to do it like this. I'll have the particle section here, like that, and we will set particle position. The lifetime of it should probably be something like 10 seconds. Right, so now here is where we could plug in the actual node that we have, and we probably need to do like we need to get the particle data and then drive this normalized age is a value that we can use just straight up with the as the t value there, right? So plug that in there, and we'll do position like that. And then we need to edit this. Let's copy that trusty piece of JSON that we have had lying around for a bit. I'm gonna save this. Oh, I lost my place there. Let's just move it into, oh, there we go, Merlin effects. Let's do testing. Put it in there and do like curve path test. All right. So then we still need to actually have some sort of visual representation for it. So we'll use, what is the diamond? Now let's use a wheel. Now let's use a cog and brick. Plug that in there. Save that and hit F9. Hey, would you look at that? There's something wrong though. Oh, I'm using absolute age. Yeah, that's not good. Just plug that in there instead. Ah, there we go. So pretty cool. We have the debug draw working. That's obviously something that we need to be able to turn off, right? Because you don't want this to be shown there in the particle effect. So we need another button there. That's good that we have a little bit of extra space. We'll add a checkbox there for that. Don't you just love it when it works? I do. It would be nice to have the. I don't think I have like a look at function. I have a set rotation, but that's not actually going to. This is going to look wonky now, but we can just plug that in there. Rotation is like an Euler thing. At least it should give us some different. it gives us some different rotations along the spline, so that's, I guess, interesting. But yeah, I should probably have like a calculation, like a node for calculating the rotation from like a look at thing. So that's cool. Okay, what else should we do? Let's modulate this somehow. How should we modulate it? Let's get a time, effect time, and then do a vector math. So let's do a vector function, like a sine wave. Oh, one sec. Quickly do one thing here. Right. Yeah, I don't think we actually want a vector function. We want a probably like a float function. It's easier to do it with this. Let's do like a sine wave here with that. Maybe do a, I don't know, a cosine as well, and then add those back into a vector. So do like an x and a maybe z, and then a vector operation like so, and just add it there. So take that, add it there like so. Now it's sort of like being a little wonky, isn't it? It's being a little wonky. It's not super obvious that it's being wonky. Let's multiply it a little bit. So vector, another vector operation. Multiply. Take this vector, add that there, and then multiply it by 10. Maybe that's actually not what I want. Instead I want to modulate the time. Multiply by, I don't know, 5. Set that back to 1. Yeah, now we can see that they're sort of dancing around that thing. Hey, fun. Maybe modulate this by like different rates. I don't know. Something like that. And now we should be able to just go in here and create another one. So we'll do yeah, we can put another curve path there. So I'm just gonna copy that guy. The first two are probably fine, and then we'll do something else. I'm gonna change the color here a little bit, make it more obvious what we're doing. And that's a really bad color. That's better. I wonder if we can actually see it against the sky there. But whatever. let's maybe make this not swirl quite that much. So we have like one, which is the sort of. I mean, I'm not going to use this as the smoke filler, but just try the concept out here. Let me get rid of that. Yeah, something like that, maybe. Let's make it like just go off there in the end towards some direction. We can take all of these and we can rotate them like that. Oh, but now we lost the start position there. There we go, that looks good. All right, so now we take, this one is third, right? Actually root is what we want again. And then we do the special command. Like so. And we just go in here and we just do another one of these guys and copy it straight into there. So now we have the other path there. We need to do something fun with this as well. What do we do? What do we do? Maybe I'll just take basically, let's take all of this for now. Let's copy it over. Oh, not that. There's the curved path. Put that there. Rotation position needs to go there. I'm actually just gonna take that away. Direction goes there. Normalized age. It's just like the off of smoke thing. Smoke pillar. And do that as well. Alright, so we have the other path being rendered there. Nothing has happened yet. What is the thing that we're missing? Yeah, so I need to actually give it a color there to actually sort of work. Yeah, that's a little annoying, but okay. Let's maybe give it a scale. This is just like super trippy with those being that numerous. So let's just do it like this instead. Scale and have a curve. Plug the normalized age into that and then just do like that. And so at 1 it will be 1. Actually, it will probably be more than 1. It can be like 3. And then just shape this curve a little bit. Just bring that up a little bit so they don't start out at like at no scale. So now they're growing. They're growing a little too slow. Alright, that is our very trippy smoke powered by curve paths. Isn't that nice? Alright, let's save this. I'm actually gonna shut that down. Unload that as well. So let's add that debug draw thing here. So we have the JSON data side and the editor side. So we need a boolean for that. Yeah. And I can almost guarantee that I will want to toggle this on at some point, but I still feel like it's probably the cleaner thing here to do is to keep it off by default. Like so. And then how do I do a checkbox? I can never remember this. I'll just copy them from some other place. So let's do like a where do we have a checkbox? Probably in many of them actually. No, not there. Right, so particle position, for example, should I? Yeah, it has a local space checkbox. Particle position, Merlin editor. Here we go. Local space checkbox. So we'll just do debug draw checkbox. And it has debug draw as the name. Like so. And that's probably the width. 20 and 30. Yeah, it should be probably like that, basically. Yep. In fact, this button is strangely sized. I think this button is actually the thing that has the sort of non-conventional size here. Not quite like that. Let's do 10, 110. Right. So now then. All right. Yeah. I'm getting a bit ahead of myself because we don't write that value anywhere yet. So it won't have any effect. But that should be a simple thing to do. So what we need to do here is write it into the stream. So debug draw. That's it. And then on the runtime side, just read it out of the stream. Bool debug draw. Now property stream get debug draw. So now then, we should be golden. Let's see, curve path, preview. Yep, you can see no debug drawings. One debug drawing and two debug drawings. Cool. Yeah, it might be kind of handy to have the color selectable there as well. but oh well. All right, this is cool. And of course, it's a little too obvious in this particular case here that what we are actually doing, but it should be pretty easy. I'm hoping it is pretty easy to actually modulate the positions in such a way that it's not obvious that we are just following a curved path. And we should also be able to actually, yeah, one thing that could be kind of interesting, let's try this. Let's get rid of this stuff. Move it up to the side there. Bye bye. So now if we just restart it, now they follow the thing just exactly, right? Yep. What was I thinking about doing? I already forgot what I was thinking I would do. Oh, yes, now I remember. Now I remember. So, vector, let's rotate a vector. This is in local space. That's fine. That's actually an add of 0, so it does nothing. Let's take the position, put it here. I wonder if this is actually like a direction that this rotates. Rotate vector, what does that do? Let's have a look. Rotate vector node. Yeah, I actually don't know. I don't remember. I think this actually rotates points, which would be actually what I want. So if I take, well, this, and this should now do the same thing, and it does. Okay, cool. So if we rotate it like around the global Y, this should still do the same thing, and it does. Angle, is that in what? It's in radians. So pi would be half a circle, or half a round around the axis, half a revolution around the axis. So 3.141592, that's close enough. And we have it sort of rotated around that. That looks good. Yeah, that looks good. So it's as if we had rotated it around. And now we can of course do random float. Random float. And we just do what should we do? Should we do like a whole revolution? So that would be 6.28 31 84. Now we press F9 and whoa, hey. Now it's being crazy. And the reason it's being crazy is that we get a random value every time we sample that thing. So that is crazy indeed. What we can do here is just select that value once before we start the updating. Vector, we need to pack that into a vector. Like so. So we just select that once, we store it in the X value slot 0, like so. Then we can do retrieve particle value. And then we need to decompose it. Vector decompose. And we use this instead. And now we should get a much nicer. Hey, isn't that nice? That looks kind of cool. Let's do something similar with this thing here. Let's do a store, put it right after the emission. We can actually take that debug drawing away. And we'll do a random value there as well. So we need to pack it. So let's pack it. So before you come to this update particle, this is kind of like the initialization phase. It's not super obvious here because this thing is just like built straight on top of this node graph thingy here. But you emit the particle, then you do something to it, and then you come to the update, and whatever comes after the update, that's sort of like then during what happens during the lifetime of the particle over and over. So before this, you can do things like select random values, things like this. So let's do a select random scale. We'll select between 0.5 and maybe 3, like so. And yeah, we'll multiply that together. So we'll do a float operation, multiply that value by that value, plug it in there. And we'll get some different sized things out of there. Our weird looking thing. That's kind of interesting, I guess. 3 is maybe a bit large. No. Yeah, something like this. Maybe we'll actually make it. Let's make it go down again towards the end there, and then we'll need to actually bump it up. Something like that. And then they sort of go away towards the end. And we can make it even more random by doing this. I don't know. This is the sort of thing where I'm really, as I said, I'm very much not a technical designer or anything like that. I haven't done any particle effects really ever for anything serious. So I just need to test what looks cool. many cases I just do something, and then sooner or later I get something kind of nice looking. I want the end there to be a little more abrupt. All right. Anyway, I think this kind of proves the point, proves the usefulness of these curve paths, right? Let's move that a little downwards. I want to make the scale of those guys. Oh, we don't actually change the scale, so I can just do it here once during the startup phase. Random float there. Scale. .75, 1.25. Yeah, looks kind of interesting. And of course, now we can build this thing. Curve path test. Save. Go back to the editor. And we actually open the proper level. It's really large, that text there. Let it render the light probes like so, and then we do Merlin. Bloop. I need to get the path of that effect. It's not being played. Is it being played? Right, it's being played here. Oh. Okay. So we have some space crap going on here. So this is now right. We need to toggle that, right? And we need to toggle that. And now it's working. Yay. All right. Yeah, this thing is just working completely in local space currently. You don't need that to be the case though. You can use like an is it effect transform? Yes. So you can do like world to local or local to world for both directions and positions if you want to. But this particular effect is, or shall we say that the smoke pillar as I have envisioned it is supposed to be just kind of like played from a single place. Seem to like move exactly smoothly. It might be something to do with I did work a little bit on the update for the Merlin effects to make them frame rate independent, because they actually weren't previously, and that might have something to do with this. Well, yeah. Yep. Progress. Yeah, like in particular, like how the cogs move. It just kind of looks pretty nice, and it's not like obvious to me at least here that they follow any kind of path. It just kind of looks like they're hanging around near that thing. So I'm hoping that will be convincing. Oh, Jesus, so much work with these particle effects. I wouldn't believe. I did actually look previously at integrating FX here, which is like seems to be a pretty nice particle engine editor thing. But I would have had to write a renderer for it, and it was, shall we say, not that clear to me how to actually do that. And they were just in the, I think they're actually still like sort of like in a transitional phase between like 1.7 and 1.8, and like the documentation was completely out of date and all of that. And I was like, I don't want to do that. But I also kind of don't want to work on this particle effect system anymore. I kind of just want to have nice effects working. So I will need to kind of wrap up the tech work for this pretty soonish, but this is promising. This is promising. What does this look like from like a far away distance? I think the trick here is to like make it less predictable, right? Like currently we're spawning those at like roughly the same rate, and we don't want to do that. We want to spawn them very occasionally, I'd say. Right. Hey, that's cool. Okay. Yeah. So I have some time still. Let's keep going while we're at it. I'm gonna go make another cup of coffee, and then I will come back and I'll do something. I don't know exactly what yet, but I'll figure it out. Figure it out, I'm sure. Alright, yeah, I don't need to save that. Nope, I don't need to save that. If we should make it so that you can select the color for those things. Maybe that's not that important. I mean, you can always toggle off one of those. Like toggle off the debug drawing to see which one is which. Or you can label it and go like, this is the thing. Green, marsh, hello, cloud thingies. And now we know that that's the thing. Yeah. I don't know. I'll figure something out. Anyway, let's do a quick break, and if you need to leave in the meantime, then thanks for hanging out. If you don't need to leave, then see you in a bit. Alrighty then, we are back. Back in business. Right. To be honest, I haven't really decided what to work on next. I mean, I guess I should probably get started on the actual smoke pillar thing, which is going to go here in the demo level. That's kind of like the next data work. It's gonna go here where there's this fallen smokestack. We want a smoke pillar to be rising from this place and looking generally awesome. And I'm sure we'll actually have use of those curve paths so that we can actually like wind the smoke sort of around these things and all of that. That would be cool. So something that I would like to actually be able to do, which I currently can't, and that is I'd like to be able to set up like color ramps. Do I have any color ramp controls? I don't know, but anyway, so basically this, able to set up a color ramp that you can then like linearly interpolate over multiple colors. That would be very handy to be able to do. I can lerp between colors currently, that's not a problem. But it has to be done in a slightly annoying way. Like this thing, for example, lerps between, I think, just two colors, and it kind of works. We have the thing. Yeah, we have it here. We just set up two colors, we lerp between them by some value. Well, that's annoying immediately when you get to 3 colors. It's not very fun to do. Do we have any like Windows forms? Let's look here. WinForms, color ramp control. I wouldn't want to make one myself just for this. Color picker, colorizer, linear gradient. Yeah. Yeah. Not quite. Gradient label. Color ramps to dials. Blah blah blah. This is probably like part of some large library and something I don't want to necessarily use. Gradient forms. What? Alright, the images aren't really working here, unfortunately. So yeah, I'm not sure I'm really going to be doing this, but it could be kind of nice. Compare forum. So like basically ramp control. at its most simple, I guess, this would be just like a one-dimensional sort of.
Hey guys,
I just want that. I just want that image.
Really neat.
No, I don't want that. Anyway, just like a one-dimensional range where you just drop colors at different points. So I guess technically it wouldn't be like super tricky to do, but it's still like work that I don't necessarily want to do. Alright, if that makes sense. Yeah, because like the only blending is happening here between like this and this and this and this. There's no blending here, there's no blending here. It's just like the fully blended to those outermost colors. Yeah, maybe I'll do that at some point, just like a very basic version of it. That might make it easier to add things like embers and whatnot. I'm supposed to like fly around this thing, or not necessarily this thing, but like the actual one that we will place there in the level. Let's just for funsies. Let's place that smoke pillar here in this. It's not called smoke pillar, obviously. It's called Merlin. Placed Merlin effect. I think there was one annoying thing about this. That's the fact that this is just a string effect path. Do we really not have a way in Zig to, let's see, Merlin components, effect component. So it's this thing here, string property. Pretty sure we have a way to actually, yeah, resource ref property. Here we go. So where's this used? This could be a resource ref, like no problem. Texture, yeah, we don't necessarily have a type for the Merlin, you know, for the Merlin effects, but it could be just, let's see if we do this, it might just break. Let's maybe unload this thing. No, no need to do that. Self, so field name would be effect path, and this resource type ID then needs to be like a raw data file. That's it, and then that needs to go away. And I think that should now make it so that we can at least like search for that path there, if I'm not mistaken. Just build. Access denied. Oh, okay, we have it running here in this. Let's just unload that as well. There we go. Reload this guy. And now if we place one of these Merlin effects here. It's a bit slow there in the beginning when it builds the light probes. So now we should be able to browse and do smoke. Yay! Smoke pillar. Start. Alright, so it's pretty big, as you can see. The shadows aren't maybe the most beautiful thing in the world. I think the size is actually pretty good after all. It just like that. This is obviously not, that doesn't look very good. But we need the fidelity to be better, but it should be from roughly at this place here, I guess. And like what happens if we actually play this? Just to get an idea of what's going on here. The feeling for it. I'm a little annoyed, to be honest, that I haven't really put any work into this so far, because it's kind of like a central piece of this whole level is this smoke pillar thingy here. So I'm kind of annoyed and surprised with myself that I haven't put it in before now. Open main gate. Sort of get a feeling for what it's going to look like. Yeah, I'd say that effect works quite well from afar, which is of course not really anything new. I've known that for a while, since I've designed it for the other level, but it does look kind of interesting even here. And this is probably like just half the distance that we have in that demo level. But yeah, I think like the overall size is pretty good, probably. Can we actually start this? Was there like a script for starting the elevator? Move elevator up. I think like especially with the way they are dissolving there at the end, it doesn't necessarily work all that well this close, but like the overall shape, it's kind of nice. Looks like something pretty bad went down. So that's cool. Camera blocker in this elevator. That's a little stupid, maybe. I want to get out. Let me out. Yeah, you're never supposed to be up here. Actually, like annoyingly, it's this side that actually opens up. And just right through this. Hey! Oh no! Oh. Yeah. All right. Yeah, I think it works from this direction. Let's go and get ourselves a ride to the refinery. That's another place where it should look cool and imposing. I really like the smokestack with all the individual fragments fizzling out there. Looks like real life. Yeah. Yeah. Let's pause this thing and go have a look at it a bit closer. There's a thing here which you can't really see from afar, but you can quite often see it when you're this close. And all this thing here, there's some jagged edges. Here's quite clearly a jagged edge, and over here we have some jagged edges. That's because of the UV mapping. Like you have these very sort of sharp corners to this dissolving effect. Or here. Yeah, I should have the material dissolve those a little differently. Let's see how it's actually done. But yeah, I'm glad it gives that feeling of just dissolving smoke, because that is indeed the point here. Let's do, yeah, it's smoke pillar in this case. So we have a clip pixel node, which quite simply clips the pixel, which is how we dissolve the thing. So like here, all these fragments have been clipped. We get a value from 0 to 1. Yeah, so 1 would be like clipping it. Apparently I'm remapping it to like 0 to 9 for some reason. And then solid noise. Yeah, with the UV. Like if I could get the local position here. Right, let's see. Let's look at the generated code. That position is, I haven't done shaders in like for ages, but that's the world position, right? I mean, it basically has to be. SSAO position, clip position. There we go. VS local 5. That guy is, yeah, so it's a world position. If I could get the local position, I could probably just sample this node using that instead. Yeah, biomatrix would allow me to get rid of the or sort of dissolve the edge a little bit, but I don't think I should really need to do that. If I just use the object local position instead, right, and then just sample that with the noise, or sample the noise with that rather. Shouldn't that work? Pretty sure it should. Transformation, transform vertex won't work. Yeah, am I just being like stupid now and tired on a Friday? Or is it really the case that I can't get like the local position easily here? That's kind of annoying since we have it here. VS local 0. I could maybe, just maybe, like if we look at the vertex shader, I could just take that. Let's close that. So the vertex shader, now the position here. What if I do something really weird like this? Let's do a vector decompose and pair it with a vector, and we set that to a vector 2. We take the position, we use the x and y, maybe, I don't know, or x and z, I don't know, let's use x and y and plug it into UV1. Right? And then we just use UV1 here instead. Right, what's that gonna look like? It's not gonna be funky. Let's build that, see what happens. Yeah, look at that. Now we have this thing going on. Is that better or worse? It might be good, but I think the scale is wrong. So if we do something like, just move this off to the side. Actually, I have a handy window. Set size. Set 720 is like a shorthand. Get a sensible field of view there. Yeah, we want to scale it the other way, so it's like 0.1 maybe. Right, like this. Isn't this maybe better? No, we don't use the UV map for anything, so I'm thinking it might still be a little too large, that scale. Just put it down even more. It's a little strange, but what can you do? Yeah, you get these like really sort of long strips that get left behind. Yeah, well, this is stuff that kind of needs to be tested, you know. What was the original? Was it 0.3? Yeah, 0.3. So we can do like copy that there, set it to 0.3. UV0, and then just toggle between these two and see which one is better. I think I kind of like, overall I like the original one better. It kind of dissolves in a more satisfying way. But then again, like I've said, this effect is not really supposed to be used even at this distance, so we'll see. Oh yeah, it's interesting. An interesting question. Let's go have a drive in the shadow of it and see how that feels. I'm probably gonna have to end actually in like 15 minutes. I have to go pick up a kid. So I don't think we'll be doing any more actual work this stream, just hanging around and looking at things for a bit. The light grayer ones which stay longer work better for actual big ass plants like you get from those big cooling towers. Yeah. Yeah. Yeah, you can see here that we don't have light mapped. We don't have this area light mapped, and we don't really have it sort of the grass is not sort of adjusted for being in shadow. Yeah, my renderer currently as sort of semi-nice as it can look in the sunlight occasionally, it doesn't look super nice in shadow, is my feeling. Of course this looks like extra ass now because we don't have light maps for this area, but but still. And yeah, they go sort of through those, or those other smokestacks go sort of through the smoke pillar there. So that's one thing I want to use those curves for, to have it sort of swirl around those other ones. It's supposed to be a pretty cool set piece anyway, so I have to put a little bit of effort into it. A little bit of effort is my motto with everything. Then we can just use a script here to remove the smokestack, and we can magically just drive up this thing. Yeah, and of course this looks just completely horrible when you're here. I probably need to somehow block off this area so that the player doesn't at least easily get to drive into this place. And maybe we'll even want to have sort of levels of detail here. You need to be able to see this from basically any point in the level, unless you just drive into some crevasse somewhere where you like can't see anything except for the sky right above you. But otherwise, you need to basically be able to see this thing from any place. But that's not really the same as being very close to it and just seeing all of the embers and things come off it. So I'm thinking I'll probably need to have at least like 2 levels of detail there. Yeah, looks fine. Looks fine to me. Shadows from the clouds. It's not. Yeah, well, I mean, it's not really clouds. It's that particle effect, right? Yeah, the clouds are just 2D sprites currently. Yeah, you can, I guess, technically go to these clouds if you really want to, but they're just 2D sprites over here hanging around. Hello. It's like a very big plane. You can also go to the moon if you want to. Here's the moon. We're now standing on the moon. So yeah. Well, yeah, those shadows that you saw, they were from this effect that we added. And yeah, since they are literally just normal meshes, then they can have shadows, they can have ambient occlusion, they can have they can technically even like affect nav meshes and things like that. Although that would be a little silly. Yeah, here we can see that like you do get this, yeah, like that. That's a very strange shadow right here, right? This. If someone pauses the game and looks at this, they're like, what is that? That's like some sort of Zorro design there on the on the ground. You can see the sun there between those. So I do need to do better than this for sure. But yeah, I think like the overall shape is kind of nice. Overall shape is fine, except let's not have it just run straight through those other smokestacks. Overall size is probably pretty good as well. But yeah, other than that, it's not really suitable for this set piece. But yeah, I won't be able to spend like a whole bunch of time on this. I just want to use some of my new features in Merlin to make it look cooler and then move on to other things. For sure. Still have a bunch of sounds to put in. I took a little bit of a break from sounds, even though I sort of promised myself I wouldn't. But I kind of ran out of steam with that for a little while. Sound design is tricky, you guys. Who would have thought? So I put a little bit of time into these particles instead. But it's getting good. Merlin is like so much better now than it was when before I started this. I have all the previews and everything there, so it should be much faster to do these things. All right. Progress over the last year is good too. Yeah, it is what it is. Can't say I'm super happy with the velocity, but the quality, yeah. I think this is good. It's a proper direction. It's just going a little too slowly. But it is what it is. Nothing much to do about it. But thank you. I appreciate it. Okay, well, we did some good stuff today. We did some really good stuff today. That's awesome. Where am I going? I'm going into the testing folder. There we go. All right. Yeah. This is the deployed version. I need my version that's run from Visual Studio. So this is what I wanted to do. Yeah. This is. I'm really happy with this. How this turned out. It looks awesome. Should be very useful. What was your most significant update that made you see the quality jump? Do you mean to the particle? You mean the stuff that like I just said about this Merlin system being much better? Is that what you meant, or? Assuming that is what you meant. The most significant update is this event preview thing here. Yeah, so previously we didn't have this. It was just this basically. So we had the node graph here, and you were able to preview events by basically, putting one of these guys in here. This is a really nice addition, the thing we just did actually. What did I call this? It was something like curve path test, there we go. So you were able to do this, have the thing running here in the background, and you could even turn off the sleeping here in the renderer, and then you were able to make a change like turning on the debug draw, and then you needed to actually build this thing. Save, yes, replace, and then you would see the thing update here, except it doesn't show the what? Why don't we get the debug draw? Oh, the debug draw is probably also, yeah, it's the same thing here. It's here. Okay, I need to fix this. This is a bug. Yeah, it's in local space. It's in world space. But yeah, anyway, this is how you could make changes. So we made this like blue, and then just hit F7, waited for a bit for it to build, and then it would restart here. Which is fine. I mean, yeah, you can work like this. It's not super pleasant maybe, but you can work like this. It's no problem. Now we have this preview here, which technically runs the same renderer and runs the same game even, but it just places it here at the world origin and without you having to like save anything. In the last stream we actually got this working, but I got it working basically the same way that it works in the game. So you had to build the effect, and you had to basically hot update it in the game, so run it off disk. You don't have to do that anymore, and that's indeed not how this works anymore. I've changed it since then. So now if you just make, change this from like green to I don't know, what colors do we have? Sand here. I just press play effect. It does just an export in memory and then just restarts the thing here. So then when you're actually happy with this, then you can just press F7 or like build effect here, and then it actually writes it to the disk. And this is much nicer because now we can just come in here and make a new thing, like this. What is like the simplest effect we can do? It's probably on start, emit particle, mesh particle renderer, and update particle. Just emit a single particle, the lifetime of 100. Let's make it a tree trunk. Sand thing is probably fine, and I think that should work. Yeah, there we get a tree. Ooh. A tree particle. And so this of course is very, very handy because now we don't have any files lying around. You can just test things out very, very nicely. Set particle scale, bloop, get particle data, and just have it grow, and then you just hit play and then it grows. Oh my god, it's so big. Yeah, this is the by far, I would say, the most productive, production increasing update of all of this. So, pretty good stuff. Anyway, folks, I think that's all the time I have today. Would be kind of interesting to get started on the smoke pillar, but I'm sure I'll have time to do that during the weekend. Hopefully I'll have something cool to show to you soon. But I think I have to go take care of some family business. So, thank you for today. This was good. I got some work done and it was pretty fun. So, check out the Discord if you haven't already done that. Still pretty early days, but there's already some good discussion going on there. And of course, as always, like, subscribe, do all the YouTube jazz. Also, I'm fairly certain that whenever I have something that I actually want to let you guys play, I'll do that somehow through Discord. Because that is kind of like a two-way street. You can then report bugs and feedback and all of that to me. So I'm thinking I'll do that there. So if you want to be the first to know when that is available, then by all means join the Discord server. And let's keep the discussion going. Anyway, have a good weekend, everyone. Hope to see you in the next stream. And bye-bye.